Welcome back again, guys. In this video, we're going to be talking about numbers. So let's go ahead and open up another Xcode Playground. I don't know why my computer does this. Just go full screen. Let's go ahead and open up a blank project. And for me, I'm just going to call this one Fun with Numbers. Look at this. See what I have to deal with? Unbelievable. Anyways, just kidding. Xcode's a great project. I just don't know why it does that with the playgrounds. I don't think it does that with normal projects. Anyways, let's jump back in here. This should look familiar to you from the last video. We've still got our import UI kit up here, and we've got our first variable here. So let's go ahead and actually get rid of this variable for right now. Let's go ahead and write our own. So let's go ahead and create a variable. Let's call it num. Short for number, and we'll set num equal to 5. Now, before we dive too deep into this, I want to go ahead and just explain something. So you may have noticed that with the last video, we were creating things called strings, and we were just saying var first name equals and then some string. And here we're saying this var num equals 5. These are obviously different data types. So one is a piece of text and one is a number. And to the computer, these are very different things. And actually, one really cool thing about Swift is that it supports what's called type inference. And again, we're going to talk about a lot of these cool terms, but we don't really need to memorize them. It's just kind of important to have a basic understanding of what they mean and what's going on when we type certain pieces of code. So here we created a variable, set it equal to 5, and right now the compiler, if you've heard me say that a couple times at this point, the compiler is the thing that basically traces through all the code and makes sure that everything is correct, and then basically compiles it into a piece of software that the phone can actually run. So whenever I talk about the compiler, I'm just talking about the computer just checking your code and making sure that it works, and actually turning it into something that the computer can understand. So anyways, the compiler right now is inferring that this is a number, but even more specifically than that, it's inferring that this variable is an integer. And in Swift, there's a profound difference between an integer and another thing called a double. These are two things that we will use all the time, and they're not really necessarily interchangeable. And that might be confusing. You might be like, well, why is there two different numbers and they're actually different types and they're not interchangeable? Well, the reason for that is because an integer is a non-decimal number. Basically meaning that an integer would never be something like 1.5 or 2.3 or something like that. An integer will always be a whole number, like 43 or 7 or 60 or 5,284. It's anything that has no decimal place. And then a double is something that does have a decimal place. So it could be something like 3.14 for pi or anything. It could, I don't know, if you ate half the cake, it could be 0.5 or something like that. So that's the difference between an integer and a double. And again, we don't really want to use them interchangeably. They do very different things. If you don't need something to ever have a decimal, don't ever use a double. Always use an integer. So, okay, so what exactly does this all mean? Hopefully that makes sense. But right now, we've got this thing called num, and again, it's an integer, and the compiler is inferring that it is an integer because we've put a number here that does not have a decimal. So let's dive a little bit deeper into this. I can keep talking about it all day long, but you're actually going to want to see an example of this working. So instead of num, let's actually call this integer number. And then for this one, let's call it var double number. And let's set this one equal to 3.5. Okay, so again, right here, we have an inferred integer, or more specifically, just an integer. Let's not worry about the inferred part right now. So that's an integer, and this is a double. Now, this might even add a little bit more layer of confusion, but let's say var sum equals integer number plus double number. Now, this is not going to work because the compiler is going to tell us this is a compiler error. It's saying binary operator plus cannot be applied to operands of type int and double. So basically, in human English, you cannot add an int and a double together because the computer understands them as being completely different data types. So that sucks, and that's kind of confusing because a logical person would think that this would just be equal to 8.5, but unfortunately we can't do this. There is ways around it. We'll get into that in a minute, but right now let's just understand that we can't do this. So if we went ahead and changed this to just 3, this would now be an integer. And we would be able to add these together, although it's confusing because this says double number, but it's actually an integer because I got rid of the decimal. So now we can add these together, and if I click play, then you'll see 5, 3, and 8. Great, that's what we would have expected to see. So now let's go back. By the way, Command Z will undo the code that you just did. Man, you'll use this a lot as a programmer. Command Z, Command Z, Command Z. You're going to want to get super used to that. And the backward side of that is Command Shift Z. So if I Command Shift Z, I can go back, so I can redo. So Command Z is undo, Command Shift Z is redo. So anyways, let's go back to here. So let's go back to integer and double number. So now that we understand that we can't do this, let's actually do one. I know I'm kind of skipping around a lot here. Let's do one more example. So let's go back to 3. It's going to let us do this, and like we said, this is an inferred integer, and this is an inferred. Right now, this is an inferred integer because I don't have a decimal. But if I wanted to make this an explicit double, I could do this. I could put colon double after the name of the variable. I'm telling the compiler, even though I don't have a decimal on the end of this number, I want you to treat it as such. I want you to treat this as a number that could have a decimal, even though it doesn't necessarily right now. But I want to be able to divide this thing and get fractional numbers and stuff like that. So I want you to make this a double. Because if you don't make it a double and you just leave it as an integer, you're not going to get the expected results if you're expecting to get some type of decimal number. Like, for example, if you divided 5 by 2 as integers, you're not going to get 2.5. We'll get into that in a minute, but how could you get 2.5? They're not decimal numbers. An integer is not a decimal number, so that will not work. So anyways, now we've got this double and we've got this integer, and oh no, we can't add them together. That's super frustrating. Well, there is a way around this, which is to go ahead and cast this double as an integer, and we could surround it with quotes like that. And by doing that, we're saying, okay, we want to add the integer 5 to a double of 3, but we're going to go ahead and cast that as an integer. So if we go ahead and run that code, then we will get 5 plus 3 is 8. That makes sense. Well, what happens if we do 3.5? Because when we cast 3.5 to an integer, it can't be 3.5 because it's an integer. It can't be a decimal number. So if we go ahead and run that, well, lo and behold, we still get 8. And that's because it's going to go ahead and round this down to the nearest whole number, and that's what it's going to give you when you cast to a double. So the point to take away from this is that we have to be very careful when we cast doubles to integers because we might get some weird results like this. We might be expecting to get 8.5, but obviously we're not going to get that. So casting, got to be careful with it sometimes. So let's go ahead and move past all this mumbo jumbo and let's get into some more practical examples. I'm going to go down a few lines of code. Let's go ahead and create another variable, and we'll call it first num, and we'll set this equal to let's set it equal to 3. All right, let's go ahead and set it to 7, and then we'll create another variable and we'll call it second num, and we'll set it equal to 4. Okay, so based on what you know, go ahead and take a guess real quick in your mind what data types these are. If you guessed integer, that would be correct. These are inferred as integers because they have no decimal number. Now, just to show you, up here we did this explicit, we made this explicitly a double. Well, we can do the same thing with an integer, although this would be unnecessary. We could technically say that it's an int. An int means integer. So we could technically say that this is an int by explicitly saying so. But in the Swift language, this is actually not the preferred way to do things. The preferred way is to infer the data type and to not do this unless you absolutely have to. There's nothing wrong with doing this. It's not going to make your application run slower. It's not going to hurt anything. It's just not the desired way to do it. When you read other people's code, you're going to notice that they don't do this very often unless there's a very specific reason for them being so specific. So, anyways, we've got first number 7, second number is 4. Now let's go ahead and create a third variable and let's set it equal to result. And we're going to set that equal to first num plus second num. And if we run that, as you'd expect, we're going to go ahead and get 11. 7 plus 4 is 11. Well, in programming, we've got access to all sorts of really cool tools. These are called arithmetic operators, and we've got access to a whole slew of them. We've got the plus operator. We've got the minus operator. So 7 minus 4 would be 3. We've got access to the multiplication operator, which we would use the asterisk or star to accomplish. So 7 times 4 is 28. So that's pretty cool. And then lastly, we've got not lastly, but in addition to that, we've also got the division operator. So 7 divided by 4 is 1 eeks. Obviously, that's a little confusing, but like I said, it's an integer, so it cannot be a fractional number. So 7 divided by 4 would be something like 1 point something something something. So instead of that being the answer, it's just going to round it back to 1. So the answer would be 1. Cool. So those are like the 4 basic arithmetic operators. Now, the last one that we have access to is the modulo operator. Let me show you a little bit about what that looks like. So if we were to say first num modulo 2, some of you that have a little bit of an algebra background, you might actually know what this means, but to some of you, this might be new. It doesn't actually mean percentage at all. This is just the operator that we use to get the modulus or the remainder after division of a number. So if we were to divide 7 by 2, what would be the remainder of that after we divided? So it would be like we could get, if we did 7 divided by 2, there is 6 full 2's that we could fit inside of a 7. I'm sorry, it would be 3 full 2's that we could fit inside of a 7. So that'd be 6, and there'd be 1 left over. So if we divided by 2, there would be 1 extra left on the end of that. So anyways, if I run that, we're going to get a 1. So let's do another example. If we were to do, let's say, I don't know, 11 mod 3, what do you think the answer would be? Well, the answer would be 2, because we could go 3, 3, 3, which is 9. That's the farthest we can go inside of 11, and then there would be 2 left over. So we could get 9 plus 2 is 11, so that's why this equals 2. Play with this a little bit more, it'll make a little bit more sense. Now, the convenient thing that we can do with this modulus operator is, let's go back to our example of 7. We could say, so result 7 modulo 2 is going to give us 1. So we can actually use this to determine whether or not a number is even or odd. And as a human, that might seem kind of silly. Like, well, obviously we know if a number is even or odd, but the computer actually doesn't know if it's even or odd. So sometimes we have to tell it whether or not this is an even or odd number, which kind of leads us, I'm going to give you a sneak peek of conditions. We'll get into these a little bit more in another lesson. But in Swift, we could say if, and we're going to check to see if something is true. We could say if first num modulus 2 equals 0, then we're going to print this is an even number, else print this is an odd number. Okay, so in this example, what would we expect to happen? Well, right here real quick before I run it, this is obviously going to be new to you, equals equals. So this is what we use in programming or in Swift. Most languages are the same way, but in Swift we're going to say equals equals. This is checking to see if something is true. So we're saying if the result of first num modulus 2 equals 0, then we want to do this thing, else we want to do this thing. So let's go ahead and run this, and we're going to see that it's going to print this is an odd number because it doesn't equal 0. As we saw here, first num modulus 2 equals 1, which would mean that it would always be an odd number. So it's going to print this as an odd number. So if we go ahead and change this to an even number, you could try any number you want right now. I'll go ahead and change it to an 8. We're going to get this as an even number because first num modulus 2 is 0. Because if you divide 2 inside of 8, there's nothing left over. There's nothing in excess at the end, so it would be 0, meaning that this is always going to be an even number, which is why it's printing this is an even number right now. So this is a little bit much right now. We're going to get into conditions a little bit more, but I just kind of wanted to talk a little bit about numbers in here. I hope the difference between an inferred integer and an explicit integer and the difference between an integer and a double makes sense. To recap, an integer is a number that is a whole number, no decimals. A double is a number that does have decimals. And then lastly, an inferred variable type is when you do not tell it what the type of this variable is. You just let the compiler figure it out. So we just said integer number equals 5, and just because it's a non-decimal number, it's going to infer that this is an integer. And then in the case of the double, right here, we explicitly told it that it was a double. So I'm going to go ahead and put explicit double right here. So if you save this, this will make sense to you. So that wraps up the numbers course, and let's get going on the next one.